Okay, so we're going to start off by doing a sweet tea experiment. Now, here will be the tea, and here's the sugar. And so, the sugar is the solvent because it dissolves and separates into parts into the solute, which the solute would be the tea because it consists of the dissolved sugar. So let's add the sugar and watch it dissolve. There it goes. Reese, does it look like the sugar dissolved well in the tea?
Yeah, it did.
Okay, so since the sugar dissolved easily in the tea, that proves that the sugar is very soluble. So you can take a look at that. Okay, so that means that it also has high levels of solubility because it's very capable of dissolving in the tea. An example of a variable being insoluble would be putting sand in water. So here we have a cup of water, and we will add some sand to it. Now, a lot of sand. Okay. Reese, does it look like the sand stayed at the bottom of the water?
It did.
It did? It didn't dissolve?
No.
Nope. Okay, so you can see there that So since the sand is staying at the bottom of the water and it's not dissolving, that proves that the sand is insoluble. It's not dissolving because it is more dense than the water. It's just staying right there. Since sweet tea is a solution that consists of solutes, or the sugar, dissolved in a solvent, which would be the tea that dissolved the sugar, we have to determine what type of solution the sweet tea is. The different types of solution that there are saturated solutions, supersaturated solutions, unsaturated, solid, liquid, gaseous, and aqueous. Now, a saturated solution is a solution containing the maximum amount of a solute within a given solvent. An example of a saturated solution would be salt and water. Water would also be the polar molecule because of the way the atoms bind in the molecule, with more positive charges on one side of the molecule and more negative charges on the other side of the molecule. Okay, so here we have the salt, and in this cup would be water. So we are going to prove that the salt water is a saturated solution. Okay, we're just going to keep adding salt until there's too much that won't dissolve in the water. Okay, so Reese, can you feel all of the salt that's at the bottom of the cup?
Oh my gosh, yeah.
Yeah. There's a lot.
That's gross.
I know. Okay, so there was too much salt added into the water so that the water could not dissolve all of the salt, proving that it is indeed a saturated solution. Another type of solution would be a supersaturated solution, which is a solution that contains more solute than it should be able to hold, but it continues dissolving. For example, maybe the lemons you used to make lemonades were a little extra tart. Okay, so here we have a full cup of lemonade. How does that taste? A little rough. Okay, so in order to offset the tart taste, we are going to add more sugar. Okay, we are going to keep adding sugar until the tart taste is a little less tart, and yeah. Okay. So how does that taste, Reese? Don't spill. Okay. This makes lemonade a supersaturated solution because the lemonade was able to keep dissolving the sugar more than it probably was theoretically able to hold. The more sugar that we added, the more it continued to affect the taste, proving that lemonade and sugar is indeed a supersaturated solution. So back to the sweet tea, since saturated solution was the salt water that would no longer dissolve, and a supersaturated solution was the lemonade and the sugar that continued to dissolve, the sweet tea would be an example of the unsaturated solution because the sugar was able to continue dissolving in the tea at a given temperature. Okay, so here we have a deflated balloon. When a balloon is deflated, the air inside the balloon isn't as compacted as when it's full. See, how does that feel?
Squishy.
Squishy? You're right. Okay, so we're gonna blow it up. How does it feel now?
It's firmer.
It's firmer? Let's add a little more. How about now?
Want a little bit more firmer.
The pressure inside of the balloon increases as more air is being blown into the balloon and compacted inside. This is why an inflated balloon feels firmer. Here we have a bottle of soda. We are about to witness a liquid solution, okay? Okay, you can see the bubbles forming. And then they will continue to dissolve into the liquid. And since the carbon dioxide within the bubbles, you can see them dissolving into the liquid, that proves that the dissolved bubbles in the soda is a liquid solution. Here I have a glass of water that I'm going to add vegetable oil to. Oil is a pure hydrocarbon which is said to be nonpolar. A nonpolar molecule has the electrons equally distributed along the molecule and do not concentrate them at the end of the molecule. The opposite ends of the nonpolar molecule do not possess abundant charges. Polar molecules dissolve polar molecules, and only nonpolar molecules get dissolved in nonpolar solvent. Water is a polar compound, and oil is nonpolar. Therefore, water cannot mix with oil, as polar and nonpolar liquids do not mix with each other to form a solution. What causes an ice cube to melt? Well, ice is formed when the temperature of water drops below the freezing point and it changes from a liquid to a solid. Temperature is the intensity of heat present in a substance or object. When the heat intensity drops, the temperature is decreasing, water is hardening, and ice is forming. Now, when heat intensity increases, the heat is causing the ice to melt and return to water in a liquid state. Let's say that water was frozen in a 2 by 2 inch cube. If we wanted to find the measure of the total area that the surface of the ice cube occupies, we would square the 2-inch side measurement of the ice cube times its 6 sides. This would mean that the ice cube has a surface area of 24 inches squared. Let's say that we have a balloon. Inside of the balloon, gases such as nitrogen, oxygen, argon, carbon dioxide, and hydrogen are mixing together and forming a gaseous solution, which we know as air. Copper combines with zinc. Brass is the solid solution that is formed. Since zinc and copper are both solids mixing together, they form a solid solution. Here I have a glass of water. As I add apple juice to the water, you can watch it dissolve into the water. This means that the apple juice is the solute since it dissolves, and the water is the solvent since it consists of the dissolved solute. Since water is the solvent, this also makes the apple juice in the water an aqueous solution. Hey, didn't see you there! Okay, so Reese, does it look like the sugar dissolves easily?
Oh,
That would be a yes. An example of a variable being insoluble would be sand. I shook the lemonade. You can see that the sand did not dissolve in the water, which means that the sand is insoluble since it didn't dissolve easily. It's just staying right at the bottom of the water because it is... Okay, back to the sweet tea. We need to... A saturated solution is a solution containing the maximum amount of a solute in a given salt... No. Be free.
Oh,
Here we have a can of soda. That proves that the soda is...